Hello, how are you doing? This is Software Download Demand. Today, I come back with another ansys tutorial on the fracture mechanics analysis by using ansys workbench. As you know, fracture mechanics is the new, uh, very recent part of science, which consider the fracture or the failure of material due to initial crack. In this particular video, I will show you we create the geometry surface body with very small thickness, but this thickness not affect our analysis since we're doing a 2D behavior analysis. We just use a structural steel material for this illustrative example, and we create a coordinate system as the crack tip, and there will be the inherent global coordinate system at this point. And also you can see as the meshing stage, we just used automatic method and vertexizing to discretize some local areas. That means we have to discretize in a finer way as the crack tip here, and also at this point we just drag or we just add the fracture tool of this workbench software, and we create the named selection for to indirect the premeshed crack. And at this static structure, we just apply the fixed support as the displacement as the two tips, assuming this beam, this initial crack or the nature of this fracture mechanics behavior of this material is assumed or assumed like a double cantilevered beam. And as a solution stage, we extract the equivalent stress as seems like B, and also as a total deformation. And also you can see from the stress tool, we try to see the value of stress intensity factor due to opening mode or this double cantilevered beam nature. So in this video, I'm gonna show you how can you do all those things step by step by using a workbench. Stay connected. Stay connected. I back after a break, and this is the Ansys workbench window. To start such analysis, we have to open static structure to this project schematic window. Let us do everything step by step. So the second is engineering data or the material or the assignment for this analysis. So structural style is the default material as usual for Ansys workbench software. So it's accepted. If you want to change the material with the assignment, you can change it from engineering data sources. So for this case, let me accept and proceed to the next step, which is geometry. So let us open the geometry by using new design model geometry here. Before that, from here the geometry or the engineering static, from here the geometry, let us change the analysis step from 3D into 2D because we are doing a 2D analysis. And then from the design module, let us just millimeter as a unit and start our sketch here. Let us select one plane and make it normal to or look at, and then let us create a rectangle, and then let us dimension it as usual. This will be 50 millimeter. Again, this will be 15 millimeter. And then let us again draw the initial crack here. Let us create that. and let us modify, let us trim this part here, and then let us dimension it as usual. Let us hold the vertical dimension selector here, the dimension from here, this will be 1 millimeter. Again, this will be 1 millimeter, and also the horizontal will be from here to here. Skip horizontal. This will be 5 millimeter, and then from here concept surface from sketches here, let us select the sketch, let us apply, and the thickness let us take as half millimeter thickness, and then let us generate this one. And then from create a concept here, split edges, let us select this edge, and the definition will be frictional. Let us give 10% of that is splitted, so let us generate. So as is the splitted edge. Again, from concept here, split edge, let us select this edge. This will be 90% of the length will be splitted. So as you can see from here, here is the splitted edge. So once we do everything on the result modeler, we already finished what we have to do here. So let us close this one and proceed to the next step, which is model. So let us refresh this model. The mechanical and workbench will open like this. So as you see from here, the project tree, we can see everything from the display here. So I will have to do everything step by step. So the first thing will be checking the geometry here. So as you see from here, the geometry is a structural steel, and from the model, from the geometry, we have to check, we have to change the 2D behavior into a plane strain condition, because we are doing a 2D analysis. And then from the material tree, we just we only use the structural steel or the assignment of the material steel. And here is the global coordinate system. From coordinate systems, we have to insert the local coordinate system at the crack tip. So x is in the direction of crack growth, and y is in the direction of load or perpendicular to the crack plane. And from the mesh stage, we have to insert the method for this body. Let us select this body, and then the method will be quadrilateral dominant. And from meshing again, let us insert sizing here. So let us select this crack tip again, and also type will be a sphere of influence. So let us define the radius as 3 millimeter, and also the element size as 0.5. So as you see from here, the element within this sphere is discretized into 0.25 element size. And let us generate this mesh. Now this is the math course, so let us adjust the element size into 1 millimeter, and then let us update this one. Seems like good is better than the previous one. And let us create this crack tip. Let us insert, let us create the named selection here, named selection. And from the named selection, let us create the node, create nodal named selection here. And let us select the model here, and let us add the fracture mechanics tool here. From the fracture mechanics, we can insert CC from here: arbitrary crack, semi-elliptical crack, premeshed crack, and surface delamination. Contact debugging and macrograves tools are added here. But in this illustrative example, I'm gonna show you only the premeshed crack only. So let us select premeshed, and then the crack tip named selection will be this one. And once we add this premeshed crack tool, the next will be you have to insert the boundary conditions, like the fixed support, this one. And then let us insert the displacement at this edge, and to 0 in the x, and in the y it will be 0.5 millimeter. And again let us insert the displacement boundary condition in the downward direction again, and similar manner. So I 0 in the x, and in the y it will be negative 0.5 millimeter. From the analysis thing, let us make the number of steps 3, and then from the solution stage, let us see the total deformation as equivalent for my stress, and let us add the fracture tool here. The crack selection will be a premeshed crack here, and then we see that the stress intensity factor due to mode 1, that means the opening mode, so the stress intensity factor will be C. So the solution will be result set. So let us solve all those results. The solution is done. This is a total deformation. Let us make it a true scale. So it's the total deformation of the body, and also you can see the equivalent normalized stress with lax B. So it is the normalized stress seems like logical because the stress distribution of the crack tip seems like this structure. So the maximum stress at the crack tip will be 65,143 megapascal. So let us I think it is at the crack tip. So at this red portion, the crack tip stress will be 35 gigapascal around. And also you can see the stress intensity factor as 13.9 megapascal millimeter as the power of 0.5. That means this is the stress intensity factor of this material under this loading condition. So to check whether the crack will propagate or not, you have to compare the stress intensity factor with experimental results. And besides this, you can insert the results. But I think you can extract any result by your own interest. For the time now, I think this is enough. If you have any question related to this problem, you can put on the comment box. I'm online. I will give you my feedback. Next time I will back by another more advanced fracture mechanics tutorial by using this software. For the time now, I finished what I have. I hope you enjoyed on my video. See you later.